Okay, this is one of my favorite examples from a digital logic course. We had talked about, when we did number representations, we talked about using 2's complement, and one of the advantages of using 2's complement is that it has built-in subtraction. So what we're going to do here in this video is we're going to walk through taking a 4-bit ripple carry adder. Not so much important that it's ripple, but it's a 4-bit adder. And we're going to have a way of converting this into a circuit that does both addition and subtraction. Okay, so you're familiar with the 4-bit adder that we have so far. And so here's an example of 5 plus 2 is 7. I've got 5 represented as 0, 1, 0, 1 for the A register. And 2 represented as 0, 0, 1, 0. So if I flip this to a 1, all right, now it's 5 plus 3. I had a 1 and another 1, and I had the carry out that went to the next stage, and it affected the result. In fact, it carried the rest of the way on through because it rippled all the way through to become an 8. All right, so we'd talked about this before. All right, so this time I didn't use a half adder. I stubbed in an input because I know my goal is to make an add subtract circuit. We're going to use this input to help us accomplish our goal, so be watching for that. Okay, so we already know about a ripple adder. Let's now take a look at how we're going to use this input. But first, what we need to do is talk about a way of doing an inversion. Okay, so the exclusive OR, one of the things I think of is an exclusive OR can be used as essentially a programmable inverter. All right, so by that I mean you have a control signal. If I make the control signal a 0 and I have an input, all right, so 2 possibilities on the input, x equals 0, x equals 1. All right, if the control signal is 0, the output with exclusive OR would be 0, 1 here. All right, so it follows the input. On the other hand, if I make the control line equal to 1 for these 2 inputs, when x is a 0, when x is a 1, notice what happens. X exclusive OR with the control line flips the bit and I get an inversion. Okay, so that's part of the secret. What we're going to do is we're going to use this inverter to make, this exclusive OR to make a programmable inverter. So when the input's a 0, it's just modeled, you can think of it as a plain wire. Whereas if it's a 1, it's doing an inversion. It's taking x and forming x bar. All right, so here's how this is relevant. We are now going to control the vector b with a subline. So this is a signal that tells us when we're going to be doing subtraction. So notice if I had 0, 0, 1, 1, when sub is a 0, I'm exclusive ORing that control line with b, so I'd get b right back. All right, so I don't get, I don't get the inversion in this case. All right. So it's labeled b prime, but that's only when you get the inversion here. So if I put the subline equal to 1, notice what happens. I have 0, 0, 1, 1. Now it's inverted to give me 1, 1, 0, 0. So no inversion, inversion by this control line. All right, so that is helpful. All right, so now we can go to the next step. In the next step, we're going to take the same adder as before, but we're going to make it do subtraction by representing the b vector in 2's complement. Okay, so remember, if I take the 2's complement of that, essentially I'm turning that into a negative number. So instead of 5 plus 3, 5 minus 3 is the goal. All right, so I can do that by putting in the exclusive OR gates and having a sub signal, all right, that tells me when I'm going to do subtraction. It's going to negate the B register by flipping all the bits. All right, and remember how we do 2's complement? We have to flip all the bits and add 1. So if I take this 1 signal here and put it to the carry in, I'm essentially injecting a +1 into this process. So flip all the bits and add 1. I now do 5 minus 3 instead of 5 plus 3. Okay? So on the other hand, if it's not flipped, if that's a 0, it's 5 plus 3. When that's flipped, it's 5 minus 3. So I'm using 2's complement to generate the negative of B. And now I can do an adder circuit that also does subtraction. Okay?